Hello, and thank you for joining us on our live webinar. I'm Jen with the Micronaut Foundation, and I have the pleasure to work with the awesome Micronaut team every day. And today we're super excited to have Gerrit here. He is the Senior Developer Advocate with Azul, and Sergio, the Micronaut Product Development Lead. Both are active members of the Java community, and you can find them speaking at various events around the globe. So today in this complimentary webinar, Sergio and Gerrit will introduce CRaC and how there is support within the Micronaut framework. There will be live demos to illustrate how it all works together. So we're really excited to see this. We will do a live Q&A session at the end and answer as many questions as time allows. So please remember to load up your questions in the Q&A section as you have them. We are recording the session and do plan to make it available to view on demand in the days following this live presentation. I believe that's it for me, and I will pass it over to Sergio so you guys can get started.
Thank you, Jen. Let me share my screen. You have to allow me to share my screen, Jen.
Okay, I can do that.
So first, let's start with Gerrit. What does CRaC stand for? So CRaC is an acronym.
Yeah, it's Coordinated Restore at Checkpoint. That's what it means.
Exactly. And I think originally it has a lot of influence in the CReO name as well, right?
Yes.
Because CReO stands for coordinated as well.
Yeah, that's Checkpoint Restore in User Space. That's the CReO acronym.
Exactly. So now I think I'm able to share my screen. There you go. So everyone should be able to see my screen.
Yes.
And I have here in another monitor the chat window open. So if anyone has any questions, please don't wait until the end. You can write it in the chat, and Gerrit and myself will answer them as well as we can while talking. So as I was saying, CRaC stands for Coordinated Restore at Checkpoint. Second important bit is CRaC is open source, right, Gerrit?
Yes, that's true. So it's open source like the OpenJDK. So it's available for free. And it's an OpenJDK project. So that means we hopefully will see it at some point in many more distributions.
Exactly. We will talk about CRaC availability in different JDKs in a second. So let's put a pin on that. What are the goals of the CRaC project?
Yeah, it's you probably heard about the JVM is so slow. When I started up, it takes forever. So especially if you have serverless stuff, then you hear that a lot. And this is mainly related to JVM startup and warm-up. And the goals of the CRaC project is to at least make it better in terms of getting faster startup or even faster warm-up. And that's in principle time to first response. We try to shorten that as much as possible. That's the main idea behind CRaC.
So where does the time go when we say like Java is slow to start? What's the process? Where is the time being spent there?
Yeah, it's interesting. So it starts with class loading first, but this is something which is not related to CRaC. And then when you come to really the bytecode, then it will be first be interpreted by the interpreter. It will be profiled and then will be compiled by the C1 compiler and then by the C2 compiler. So and this whole process takes some time. And also you have to touch a lot of these classes right before you really get to the time where you get the first response of your application. And because there are certain thresholds, so that means the smallest let's say unit that will be used for optimizing code in the JVM is a method. And so the first time you run through the interpreter, it will count how often will a method be called. And when it reaches a threshold, it will become to the C1 compiler, will be compiled, and the same for the C1 compiled methods before it gets into C2. And then it gets optimized and all that. And this whole process can take some time because the JVM does this speculative optimization. So it does stuff like branch analysis and all these things. and that it can go wrong. So that means it has to de-optimize again. And so it just takes some time to get to the optimum performance level of your application running in the JVM. So that's a very short explanation of what's going on.
But just so for everyone is, so a Java application that has been run and that has been sufficiently invoked, the compiler will optimize the code so that it's really fast. So a Java application that has been running for a while is not slow at all. So it's going to be fast. And what we want to, in an ideal world, what we would like to have is like the speed times of a warm application, but just from the get-go, right? Just from the startup.
Exactly. We would like to have the full performance directly.
And the problem also is that nowadays we have many scenarios where we are doing this over and over again, right?
Yeah, that's one of the biggest problems, right? So if you have an application, the JVM it's great, right? So it does a really awesome job in optimizing the code and running it greatly. But it came from this monolithic world where we have an application we started once and we can wait until it's fast and then it stays running for days. But these days you see a lot more often these scenarios where you start up an application a lot of times. And the problem there is that the JVM has no really a memory. So it can't really remember the last time it did all the optimizations. So that means the next time you start it, you have to go through the same thing again. And if you think about microservices, for example, where you scale up a service, every time you start it, you have to go through the interpretation and compilation and optimization phase. And this is that's a little bit of the drawback that you have in general JIT compilers, because you don't have any memory there. So you run it once, you optimize it once. When you shut it down and you start again, you have to do it again. That's the big problem here.
So the first time I heard about CRaC, I heard this metaphor, which I think it really explains well the idea, is we all have started a laptop from scratch and it is not fast, right? The first time you put a laptop, but all the modern laptops, they have like this idea of basically like hibernate the laptop and resume it. And once you resume it, it's really fast, especially nowadays. So CRaC, for me, the way I like to think it is this way, like, so you start the JVM, you start the application, you invoke it several times, and then you put it to sleep, and then restoring is just wake it up from sleep. And at that point, the application should be really fast. I did something strange from the deck, and I wanted to do a spoiler just at the beginning of the deck, and I took these measurements in a Linux laptop that I have here, which is really resource constrained. So I am not really worried about the absolute numbers. What I want you to focus here is on the magnitude of the improvement that you will get out of the box. And this is the same application, and I'm gonna show you the application that these numbers are about in a second. But this is the kind of startup improvement that you're gonna get without any effort on your side, and I will show you what I mean by zero effort on your side in a second. Back in the beginning of the talk, Gerrit mentioned that the hope is that CRaC becomes available in every distribution of the JDK, but right now it's only on Azul, and you guys had big news last week, so can you talk about it?
Yeah, so we thought that because it's an open JDK project, we thought it might be time to do an implementation of that open JDK project into our Azul Zulu core project or product, which is a free available OpenJDK build of Azul. And we added CRaC support into this officially released version of Zulu. And it's 17.07, so it's the latest one. And as you can see, it's only available for Linux x86 and on Linux. Yes, I mentioned that already, but we will come to that later on. Yeah, and we made it available for public, for free. And even if you need support, of course, you have to buy that, but you can get support for that. So we will help you with this. So if you run into trouble, you can ping us. There is a forum on the Fuji.io website related to CRaC where you can put stuff in if you run into problems. So we would just like to see people picking up that idea and play around with it and use it. And we hope that more distributions will support it because we think it's a good idea.
Absolutely. Let me show how to do that. So I have here, so I am running macOS, and let me see if I am able to make the terminals below the Zoom window. Otherwise, I will never see that what I am writing. So let me log out from this machine. So this is the terminal running on my computer. And if I do here, so I am running SDK Man, which for those who don't know, it is a wonderful free tool to essentially control many different versions of things such as Micronaut or any framework, Quarkus, Spring Boot, build tools such as Gradle, but also Java distribution. So you can do here like SDK list Java, and you will get like available Java distributions for my platform. So you see like Corretto, GraalVM, Java.NET, Liberica, Microsoft, and Zulu. And you see that these Zulu distributions, they don't have any CRaC version, and that's because I am running macOS, and currently there is no Zulu JDK which supports CRaC for my platform. However, if I SSH into an Ubuntu machine, an x86 Ubuntu machine, so I'm gonna do here gonna log into my Ubuntu machine, and I'm gonna do here sudo -s. We'll talk more about being root in a second, but if I do here SDK list Java, you will see that the Zulu distribution has, for example, a 17 distribution that supports CRaC, and it has the CRaC name on it, so it's really easy to install. So with SDK Man, you will just do something like this, which I have already done. So you will do SDK install Java, and you will pass the name of the distro, and that will be it. And if I do here, because I already installed, so if I do SDK use Java, and if I do Java minus version, you see here the CRaC. So installing a JDK which supports CRaC is as easy as doing this step. Instead of use, you will just write SDK install, and you are good to go. So I created a list of a checklist with things that you have to put in place in order to use CRaC in your project. And the first one is to use a JDK with CRaC. We saw that. So you use the Zulu distro that they released last week. You will cross the first checkpoint. The second one is the add the CRaC API dependency. And this is something that you could. So you publish this API, which is really simple, which we'll show in a second, and you distribute it to. I think it's in Maven Central, right?
It is also available via Maven Central. Yes, if you search for org-CRaC, you should find it there.
So really easy to use, like any other dependency, right? You just add the dependency in your Maven build or in your Gradle build, and you will have the API there. The API, if you go to the CRaC documentation, which I'll have a link at the end of the slides, it will tell you like about two concepts. One is resources, which I will show you in a second, and the other one is registering those resources in the CRaC context. So we in the Micronaut framework, we have support integration with CRaC, and what we have done is we have a dependency called Micronaut CRaC, which has a transitive dependency to the CRaC API. So you don't have to add the CRaC API directly. In the moment you add the Micronaut CRaC, you are actually transitively adding the CRaC API. So that's checkpoint number 2. The third one is write resources to close files and connections. And this is another CRaC constraint, right? So the idea is that you run the application, you checkpoint the application. So you create a checkpoint. That's when you essentially put your application to sleep. And in order for that checkpoint to be successful, you cannot have any open connections, right, Gerrit? So that's the rule.
Yeah, that's correct. Because you can imagine if the application is running in the JVM and you put the JVM to sleep, then it will mean it will close all the connections. You have to close them, right? So because if the JVM is not running anymore, then there's no connection to the outside world. But when you restore it, then how should your application get back to the database, for example? Because it won't automatically reconnect to the database. This is the reason for the API that we added. So you have to let the application know when it will be checkpointed and where it will be restored from the checkpoint. That's the main idea. And therefore you have to close files and sockets, and then you have to reopen them after the restore.
So this is the API that the CRaC API. So you see the API for a resource is pretty easy to understand. It's a Java interface with two methods. One is before checkpoint, which, as you can imagine, will be invoked just before the checkpoint. And the other one is after restore, which means once you are after the restoration from the checkpoint. So one will be just before the checkpoint, and when the application is restored, when it's coming back from sleep, the second method will be called. In Micronaut, we have another API called ordered, and this API is basically used in places in the framework where you need the beans of a particular type to be executed in order, right? So it's pretty simple. If you don't care about the order, then you just don't change the method that has a default implementation of 0. And if you care about the order, then you override the method, right? So what we did is we have an interface which essentially implements both the CRaC API, the resource CRaC API, and the order one. And we were really original and we call it ordered resource because that kind of makes sense to me. So how do you register resources in a Micronaut application using CRaC? Really easy. You create a class. You implement the order resource. By implementing the order resource, you're going to be forced to provide you're going to be forced to override both methods before checkpoint and after checkpoint. If you don't want to do anything, then don't do anything in either or. Here I am just logging before checkpoint and after restore so that we see that when we execute. And the other thing that you have to do is this must be like, so I annotated with a singleton because this is going to be a singleton in my application. And that's it. That's the only thing that you have to do. We ship with several built-in order resource, and I imagine we will be adding more and more of these. So right now, for example, we have a Netty embedded server resource, which will essentially do the closing of Netty and restart of Netty after the checkpoint. And we have another one for data source resource, another one for Redis. So the idea is that when you use Micronaut, which any of the Micronaut runtimes or different Micronaut integrations, ideally as a developer, you're not going to have to do anything. We will ship with those resources for you that take care of closing anything that needs to be closed before the checkpoint and reopening after the checkpoint. So as of today, you can have a Micronaut application using the Netty runtime, which is our default runtime, with microdata JDBC, which is probably our more exciting persistent technology, with Hikaria's connection pool connected to a relational database such as MySQL or Postgres, and you don't need to write any code. So basically, this will work out of the box. You don't have to write any CRaC related code. The only thing that you have to do is add the dependency to your application, and we take care of the rest. If you do need to, because your application is doing something of your logic and you need to do any closing of connections or anything as you saw before, it's really easy. You just create a class, annotate it with a singleton, implement the order resource, and you override those methods to fulfill your needs. Another thing that we have is the refreshable scope. So Micronaut has, as many other frameworks, we have different scopes. We have like the prototype scope, the singleton scope that I saw you, and the refreshable scope. The idea with the refreshable scope is you will use it in a bin where you want the state of the bin to be refreshed, and typically you refresh the state programmatically either by triggering a refresh event or by hitting an endpoint called refresh. And this is a behavior that you can turn off, but by default, whenever before checkpoint, we will issue a refresh event. So all the states of these bins annotated without refreshable will be automatically basically clean up just before the checkpoint. So this, I think, will be really useful for users. So in many cases, you don't even have to write a resource. The only thing that you have to do is annotate your classes that they make sense to be refreshable without refreshable, and this will work nicely in the application logic. And with this, we will have the second one and the last one, which is register resource in the CRaC context. We will do for you automatically. So Micronaut CRaC registers automatically any bin of type order resource in the CRaC context, and we will do it in the order. So if you register, you use the order resource to register resource A, B, and C. Upon restoration, they will be restored in the opposite order. So they will be restored in C, B, A, because it makes sense that basically the order is reversed upon restoration. So you don't need to interact with the CRaC context. If you need to, we provide you a bin, which, if my memory serves well, is called CRaC context provider, but typically you never need to interact with this. The only thing that you have to do is create your resources and maybe tweak the order to fulfill your needs. And this is a point, the last point. I'm going to show you the application that I'm going to be demoing in a second. So I have here IntelliJ open. Let me make here presentation code, which I never remember how to trigger. So let me trigger with enter presentation mode. And really simple application. I have a hello world controller, which returns hello world, nothing fancy. Micronaut response JSON by default. This will be the root endpoint of my application. So when you do like a localhost 8080, which is the port that Micronaut applications start by default, we will get like a JSON response. I have my application, and I have one thing here interesting, which is I eagerly initialize all the singletons. So Micronaut bins by default are lazily initialized, and this makes sense when you are not using CRaC. But when you are using CRaC, it's interesting for you that you eagerly initialize as much as possible, and you essentially warm it up as much as possible before the checkpoint. So what we have here is we basically eagerly initialize all the singletons. So this controller, which I was just showing you, it will be initialized when the application starts, even if before we hit it. I created a login resource just to show it that we logged. What else do I have? I have here in my application, I have the Micronaut CRaC dependency. You see that I don't have the CRaC API dependency because that's a transitive of this one. And I am using Gradle. We support CRaC with both Gradle and Maven. In Gradle, we have a specific plugin called io.Micronaut CRaC. And in Gradle is in the Micronaut Maven plugin. We have support for packaging as I will show you later on, but basically Docker CRaC, you can package the application as a Docker image with CRaC as well. So we support both builds, Maven and Gradle with CRaC. And the other thing that I have here is I added the Micronaut CRaC package to trace level so that we get a bit more logs. And I have a test, which I will show you in a second, but that's the application that we have. As you see, I'm not registering anything in the context automatically. That's being done by Micronaut. And this is the CRaC constraints that I wanted to talk Jerry about. So CRaC right now is only available in Linux. And why is that, Jerry?
Yeah, the reason for that is that we use a project on Linux, which is called CREO. That is Checkpoint Restore in User Space. And it's a quite old project. It was already in the kernel in 2013, so nearly 10 years. And it was made to checkpoint an application running on Linux and then store the state in a file or multiple files and then restore it back to memory later on. So that was the main idea. You would think that, oh, the JVM is just an application on the JVM, so I should be able to just checkpoint it and restore it. And if it's just the JVM, then you're probably right, but the problem is your application in the JVM, right? So this is the reason why we created CRaC, because we needed a way to let the application know now there's a checkpoint and now there was a restore, so that you can close and reinitialize resources. So, and this is the main reason why we only have support for Linux. It's not the biggest problem, to be honest, because if we are honest, then most of the installations these days or deployments are running on Linux x64 at the moment. ARM is coming, but there are just a few people that really run production servers on Windows. I saw them, so they are there. So we don't have any CRaC support for Windows right now. And for Mac, it's the same. And one of the reasons also is, even if you're on Linux, you have to make sure that you have at least support for the proc file system. So I know there are some Linux distributions that don't really support the proc file system, and these won't run with CRaC. So this is, but the main things like Debian and all these, they all run with proc. So if they support proc, then it should work on the Linux distributions. And we also, the CRaC library that we use, we bundle that with the JDK. So because it might be installed, or it is installed in the many Linux distributions already, but to make sure that we have the right version, we bundle it with the JDK and we use the one that we bundled. So to make sure it works on all the different distributions.
Another thing that Gerrit mentioned is that right now there's only support for x86, right?
Yep. Yeah, that's right. So we are working on an ARM port. So there will be an ARM version coming. I can't really say when it will be ready, but we are planning to also support ARM 64. So it will be there. It's just a matter of time. But we will make sure that we also have support for Linux ARM 64.
Yeah. So one thing that we did in order to, so I agree with what Gerrit said, is that for production, I don't think it's an issue that it runs only Linux, because most, I would say like 90% or 99% of the industry deploys to Linux. But for development, there are many developers that use Windows or Mac OS. Myself, I am a Mac OS user. And my colleague who did most of the Micronaut CRaC implementation, Tim Yates, he's also a macOS user. And what we came up with is we created an API which you will typically use on your test class path, which is called Checkpoint Simulator. And the idea is that, so this is a test in Micronaut where this is my test, right? So let me show you the test. I have a Micronaut HTTP client. I am doing a GET request to the root of my application. I am basically binding the response to a map of a string to a string. So this is the response. And then I am checking that the response is a 200, okay. And then I am checking that the body is actually message hello world, right? So nothing fancy, but what I want to test is I want to test that my application responds this before the checkpoint. And when I restore from the checkpoint, it's still alive and it responds the same, right? So what you can do is you can start the server. You can get a bin of type checkpoint simulator. We ship with one checkpoint simulator, which we have called, I think the default implementation is called default checkpoint simulator. You run your test, then you run before checkpoint. This will execute all the checkpoints, including our login resource. So when I run this test, you will see that it's gonna output before checkpoint in the console. Then you can stop the netty server. You can run after restores, which is typically, well, so this will typically be like doing the checkpoint, right? And this will be restoring from the checkpoint. And I am running the run after restore. This is run. This is going to run all the resources in the order that will happen when you run them in real life, and then you can run server start. So this will essentially allow you to test your application as it will behave in a in an operating system with CRaC enabled, but just in your test, and then run the same test again. So if I run this test, we will see the checkpoints being outputted. So you see here, like, because I have like the Micronaut CRaC, you see here like we trigger also events. So you see here the before checkpoint. This is our custom resource that we created, and you see here the after restore that we created. So you see all the resources being executed and the test being successful, right? So this is kind of a small API that we have in Micronaut CRaC to essentially make your development lifecycle a little bit easier. So I have this application in a public GitHub repository, which you will find a link at the end of the slides. In the last slide, we already talked about the initialization. Another constraint is that you require to run as root to create the checkpoint, right, Gary?
Yeah, that's correct. At the moment, this is related to CRaC. It requires the root privileges, but we are also working on a solution to get rid of that. So to be able to run rootless. So to create checkpoints without root privileges, and also to restore. Restoring should already work without being root, but creating checkpoints, as far as I know, at the moment still requires to be root. But this is, like I said, this is ongoing work, and we will come up with a solution to get rid of the root privileges to create checkpoints.
So let me demo this. So I have here, I'm going to open two terminals, one on the left and one on the right. I am running both as root. If I manage to put them in the correct place, I have both as root. Let me put them here and move the Zoom window out of the way. So I'm going to remove a folder where we are going to save the checkpoint files. So when you create a checkpoints, there are files that are going to be created in the operating system where you checkpoint, basically. So I have here like essentially this is the same application that I was just showing you. So I clone it here to this computer. I'm going to run a Gradle assemble. So this is going to generate like a fat jar of my application in the folder build libs. I will show you in a second. So let me check which Java version I am running here. I am running the version with CRaC, right? The Zulu version with CRaC. I'm gonna start. So typically you will run the application with Java -jar build libs CRaC demo all, right? So this will run my application, and I can do here a curl request in the other terminal, localhost 8080, and you see here, hopefully you see here the hello world. So this is working as we can expect. So in order to run, we have to pass a flag, which I'm gonna check it here. So CRaC checkpoint 2. So I'm gonna do here -XX CRaC checkpoint 2, and I'm gonna select a folder in my computer. So I'm gonna do home Ubuntu. So I am running Ubuntu. This is an AWS EC2 machine running the default Ubuntu distribution, so nothing fancy. So I basically created an EC2 machine with Ubuntu with the defaults. I install SDK-man just to be able to install the Zulu JDK, and that was pretty much it. I probably install unzip, but that's the only thing I did. We have to create first I'm going to create first the folder, because I don't think I have it here. So I'm going to create here the CRaC files folder. I'm going to start with CRaC files. So I want to save the checkpoint to this folder. Just running the application, I should be able to invoke it. No problem, right? And now to checkpoint it is I have to use the J command, which I can, let me go to home, and this will help me out to autocomplete my jar file name. So I'm gonna go to Del Amo, CRaC demo build libs. So inside this folder, I'm gonna run a J command. I'm gonna use the fat jar, the same one that we ran here. This fat jar. So this is gonna be used, I think, to obtain the process ID. And then I'm gonna run JDK checkpoint. It doesn't look good. I think it crashed. Let me do it again. The mogots failed us pretty badly. Let me do home Ubuntu CRaC files. Maybe I didn't run the command correctly. Let me see if I had a typo here. Let me put this in another monitor so I can look at it. So CRaC checkpoint 2. I think that looks okay to me.
Yeah.
There you go. Let me try to do one thing. Let me try to kill everything in case I had something.
Oh, yeah, maybe, yeah.
So let me see if I am able to. So this thing is running correctly. And now I'm gonna call J command, CRaC demo all JDK checkpoint.
Huh.
It's failing. Wow.
We tested it half an hour ago, right?
Yeah. So let me see what I'm doing. Let me do Gradle clean.
What does it say?
To exit, and let me run my root again.
It says open socket exception.
So I'm gonna go now again to my project here to GitHub and kill all. So again, wish me luck. So I am running the wrong JVM. Use Java CRaC Zulu. I'm gonna run Gradle assemble. Now I'm gonna run, let's see if it works now. I'm gonna run Java -XX CRaC checkpoint 2 home Ubuntu. It's not created. CRaC files. There you go. I'm gonna run -jar build. Okay. Now I'm gonna run, you see here the resources printing out, car localhost 8080. And now we're gonna try to checkpoint it again. So I'm gonna go to cd home Ubuntu GitHub CRaC demo build libs, and I'm gonna do j command CRaC demo 0.1 all jar JDK checkpoint.
No, .jar. There you tap -jar.
Jar. Okay, now the checkpoint worked. So
Yeah.
I think the demo gods they just did a joke to us. So the checkpoint is here, right? So how do you restore from a checkpoint, right? So then my application should not be running. So if I do a curl command, you see that it's not running anymore, right? So how do you restore? You just run Java, and instead of running -xx CRaC checkpoint 2, you do CRaC restore from, and you select the folder where you save. So if I do here, if I do ls -la home Ubuntu CRaC files, you will see that there are some images that were created in the folder, right? So if I restore now, you see that it ran the after restores methods in our resources, right? And if I do a curl command, you see the hello world. So the application is running as expected. So we have an utility. I have in a project that if you are interested is under github.io, github.com, Micronaut projects scripts is the repository. So it's a repository publicly available. We have this bash script, which is time to first request.sh, which does one thing. It will run an application with Java -jar, and then it will execute this method within bash. Basically, it does a curl request, and it basically loops until the first curl request is successful. So it will essentially measure the startup time plus time to response to the first request, and it will do the same for a restoration from CRaC, and it will be the same for a Docker image or a native executable. So that's kind of all the possibilities that you have with Micron. So either a plain fat jar, Docker image of your application, restoring from CRaC, or just executing a native image, as in this case. So I'm going to run, this is going to give us some measurements. This is not like, so what I want you to think is this is going to give us like a perspective of the startup performance improvements that you're going to get. So this is an Ubuntu Linux box in an Amazon EC2 machine. I think it has 1 gig of memory, and I think it has 1 core only, maybe 2, I don't remember anymore when I created it yesterday. So I'm going to run this script. So I'm going to do time to first request, .sh, and this is going to tell me like, we even have some nice help image. So I'm going to do time to first request, and I'm going to pass -j for Java, and then my fat jar, and this is going to not use CRaC. So let me check here that this thing is not running anymore. So you see nothing is running in localhost 8080, right? So I'm going to run this time to first request script against the fat jar. And this is going to start the fat jar and do basically like a loop until it found one. Let me do one thing, which is I'm going to turn off CRaC, because it doesn't make sense that we are spending any time registering resources if we are not using CRaC. So just to be fair with the example, I'm going to turn off CRaC and run. And this took like 4 seconds and 300 milliseconds. And I am going to do the same thing, but with the CRaC checkpoint that we created. So I'm going to do C for CRaC, and I'm going to pass the folder. So this will be Ubuntu, and this will be CRaC files, files with a trailing S. And this was 151 milliseconds. So you see the improvements is orders of magnitude. So it was from 4 seconds and 300 milliseconds to only 151 milliseconds. So as you see, the code is exactly the same. I have one order resource just because I wanted to show you that you could have like an order resource, but I didn't do anything specific for Netty or for anything like that. That's all built into the framework, and the startup improvements that you get are incredible out of the box. So that's the demo. Let me go back to the slides. So I show you how to make a checkpoint from the outside, right? So I ran an application in one terminal and did a checkpoint in the other. There is another option, which is to trigger a checkpoint programmatically. I'm not going to show you that today, but we are thinking about adding an endpoint to Micronaut CRaC to essentially allow you to hit an endpoint and do the checkpoint programmatically. This is how to restore. You essentially pass the path where you checkpoint. We have a couple of other options. Our Micronaut Gradle plugin, we have a Gradle plugin called io.micronaut CRaC. And in Maven, is in the Maven plugin, you can run a Docker build CRaC, and what that will do is, inside the Docker image, it will download the Zulu JDK. It will assemble the fat jar of your application. It will run it. It will allow you to pass a warm-up script. So if you know your application and you have like all these endpoints, you could like hit the application 1,000 times or 6,000 times, or how many times do you need for your application to be warm, and then create a checkpoint. And then the entry point of your Docker image will be the restoration from the checkpoint, right? So when I come here to my application and I come here to the demo and I do Docker build, so I am running here Docker desktop here. If I run Docker build, this is going to generate essentially a Docker image of my application. And inside the Docker image, the entry point is going to do jar minus jar, right? So what we are going to see is like the time is going to be, so this machine is much faster than the Linux box that I was showing you. So even if I am running in Docker, it's going to be faster. Our time to first script is also, it also allows you to pass Docker. So you do like -d Docker. I can pass the Docker image. So this Docker image that was just created was here. It says successfully tagged with CRaC demo latest, right? So if I run the Docker image, if I run my script, this will essentially have the overhead of the Docker envelope. So this will run like 3.3. If I now run here, I could do here Docker build CRaC. And this will do, and my warm-up script by default will do nothing. It will essentially do like a curl request only. So it's not really warming up. So what you have to think that all this improvement that I am showing you today is just essentially eagerly initializing all the singletons. And can you share the CRaC files that are created? Do you mean if I can share them with you, or do you mean if you can share them with? So as far as I know, and Gerrit can correct me this, you can create a CRaC checkpoint even in one machine and run it in a different machine, right?
Yes, that's in principle possible, as long as the CPU architecture is the same. So you can't really run something, and this is obvious, you can't run an ARM checkpoint on an X or Intel architecture. That won't work. And there are also some restrictions. Even if you stick to the Intel architecture, then you can imagine that the newer chips, like let's say you have a Core i9 or something, the JVM knows that this is a newer CPU and optimizes the code for this CPU level. And that means you can't really create a checkpoint on the latest and greatest Intel CPU and expect it to run on a very old one, because the old CPUs don't know the optimization levels of the new ones. So you have to make sure that the machine you create the checkpoint on has the same architecture as the machine that you run it on later, which is usually not a big problem, because you can, whatever machine you take to create that, you just have to make sure that it's the same architecture. But you can share that. And I would suggest, instead of putting the checkpoint files not in one in the container, but you can put it in a volume. externally. And then every time you start up a service, you can even start up multiple times. It can just load the files from this volume, which is better.
Yep. So I just ran Docker build CRaC, right? And it created, actually, it used the same tag because it's basically by default, it uses the application name latest. So if I run the same command, this will run the Docker CRaC, and you see the startup improvement. So this was the regular Java 1 3.3, and this is the Docker CRaC, including the Docker envelope. It only takes like half a second to start. So huge improvements out of the box. We have a guide called, if you go to guides.micronaut.io, for those of you who don't know about them, sorry, I have to do this, but you don't see the Zoom window, but I see the Zoom window and doesn't allow me to see the rest of my screen. So if I go here, and we have a section called distribution. If you go building a Docker image, we will show you the different options. And let me show you Maven, because I am always, because I'm more like a Gradle user than a Maven user. We have support for CRaC as well. So here we show you different ways to like package your application as a Docker image. And we show you here like the commands to do it with Maven as well. So it's definitely possible with Maven. There is nothing that we are doing that is Gradle specific. And you will see the comparisons that you can get. So you can even use the AOT optimizations, which will play really nice with CRaC as well. So check it out. Is if you visit guides.micronaut.io, building a Docker image of your Micronaut application, you will see examples of CRaC there. So these are the commands. This is a link to the guide that I just mentioned. So I wanted to finish with a couple of slides about the use cases that I think are going to be really exciting in combination with Micronaut and CRaC. One of the use cases is serverless for containers. So as I saw you, generating a checkpointed Docker image of your application with Micronaut is a Gradle command away, or a Maven package command away. And there are services such as Google Cloud Run or AWS Fargate, which are basically serverless, and you essentially, what you do is you give the Docker image of your application, and they will run it. And we wrote a guide for Google Cloud Run, which you can check. Is essentially is a Hello World application such as the one that I am showing you right here. And you can, the only thing that you have to do is you essentially provide a Docker registry. You push the same thing that we did. You have Docker build CRaC. You can do Docker push CRaC, which essentially will do Docker build CRaC and then push it to the registry. And then when you start in Google Cloud Run, you just pass the URL of the registry. And the only thing that you have to, in this case, in order to work, is you have to use the second generation environment of Google Cloud Run. And what I recommend you to do is push like the regular Micronaut application, no CRaC. So just Docker build and just push it. Check the startup time of Cloud Run, and then push the same application with CRaC, and you will see like the significant startup improvements that you're going to get out of the box, and you're not going to have to do anything special. So it's going to work. If you are using some integrations, you may face difficulties because there may be something, maybe the checkpoint fails to be created. Please report that in the Micronaut CRaC GitHub repository. We're looking for people like trying this. So we have people like using this with Redis. We have people like, so we want people to try it with Micronaut has many integrations, and we have not tested all. So there may be scenarios where we have to do some work on our end, but the goal is that for you developers, you don't have to do anything, but unless you have something custom in your application, and it will work out of the box. So the other scenario is functions. So not serverless for containers, but typically like scenarios such as AWS Lambda. AWS Lambda recently released a feature called AWS Lambda Snapstart, which is basically the same idea as the, so I think they are doing other optimizations, but it's the same idea. And the nice thing is that they are CRaC API compatible. So if you use Micronaut CRaC, you can use it if you want to use it in a regular JDK, such as the Zulu JDK with CRaC, that works. If you want to deploy to Lambda, the same code with the same order resource, the same CRaC generated context, all of that will work. So AWS Lambda Snapstart will essentially call all the resources. So it will call the CRaC API before creating, I think in Lambda, they call it a snapshot before creating the snapshot. And when you restore it, it will call the after restore. So they are compatible. And the startup improvements that we saw they are significant. And so a Hello World application without CRaC, it can take like almost 3 seconds to start up in Lambda. And with CRaC, it will take like less than half a second to start. So this is called a startup. Think that in Lambda, you're not going to get a call to startup for all the requests. So you typically will get a call to startup is like, I don't know, it's like 1% of your requests will be a call to startup. And even in these scenarios, the startup, I think, is pretty decent. So you're going to get, in these scenarios, you're going to get only like half a second call to startup, which is really nice as well. And that's all I have. Do you have anything else on your side, Gary, that you would like to point before we go to Q&A?
Oh, I think you covered it all.
Okay, let me check the chat. So the lead turning question about sharing the CRaC files, I think either what Gerrit says, like putting the CRaC files in a volume and use that, or just use a Docker image of your application and put it in a registry and just reuse the Docker image to essentially instantiate main instances. Simon says it's nice to see popping up, normally speaking, also in Spring 6.1. I don't know if CRaC supports Spring, but if Spring supports CRaC, but I will not be surprised. I think CRaC is getting a lot of interest from all the frameworks because we all face the same problems in terms of startup improvements. So this is another deployment options that I think it will be really it will be a good choice for many people. Let me go to Q&A. There is a question from Leonardo Ferreira. Is it possible to create native builds with CRaC to serverless application? Can the checkpoint be shared by multiple containers or just replicated to different volumes? So the first one is it possible to create native builds with CRaC to serverless application? I think what you mean is if you can like do like a native image of your application. Yes, it will. It is a different deployment scenario. So you will not use native image like CRaC. You will use either native image or CRaC, and yeah, both have constraints. Both are really great solutions to startup improvements in Lambda. So what I will recommend you to do is try to see what works best for your application. If GraalVM works well for your application, if CRaC works well for your application, check it out, check the performance, and go with whatever is best for your use case. And the second question is, can the checkpoint be shared by multiple containers? Or just replicated to different volumes. So if you create like a Docker image of your application, you can start like multiple containers using that Docker image. I don't think there is anything special. And
yes, you can share the checkpoint, right? So this is just a set of files. That's what I mean. You can put it in volume somewhere, even in your cluster. Put it in a volume, and then you point just when you start the service, you just point it. The folder is then the external volume, and then it will load the files from there. So this is possible. You just have to create it once, and then you can use it on multiple.
Perfect. Are there any other questions from anyone?
I don't see any on my end, Sergio.
So we did just on top of the hour.
Yeah, awesome. Well, thanks guys for joining us today. This was some great information. And as I mentioned at the beginning, we did record this and we will have it for view on demand in the next few days. So we look forward to seeing you all at our next event. So check our calendar. Thanks again, guys, for joining us. And you guys have a good rest of the week.
Thanks, everyone.